Now we need to look at the greenhouse effect. Now this is a very nice graphic showing the greenhouse effect. However, there are a few errors and I will point them out to you. Stage 1. Radiation from the sun, not just in visible light but in all parts of the electromagnetic spectrum, they come to the Earth and they warm the Earth, so these rays are absorbed. Then when the radiation is absorbed, some infrared radiation is produced because the Earth is a black body. It produces a band of radiation, but mostly in the infrared. Most of this goes through the atmosphere and escapes into space. However, there are some greenhouse gases there, and they absorb some of this radiation, this infrared radiation. And here it says it's reflected back to Earth. Now it can't absorb and reflect. So what it does, it basically absorbs it and then shortly afterwards re-emits it. Now this radiation, some is re-emitted into space, some is re-emitted back to Earth. So it's absorption followed by emission, not reflection. So as we increase the number of greenhouse gases, then the atmosphere will basically, and the Earth will heat up. So we need to do a little bit more about what is the mechanism here. Radiation from the sun is absorbed by the Earth. Then the Earth heats up slightly, and it basically re-radiates this in the infrared because the Earth is a black body, or close to a black body. Now the greenhouse gases absorb this radiation, which is in the infrared, because it's that particular radiation which is absorbed by the greenhouse gases. This is the mechanism. There are basically energy levels inside the molecule that the molecule behaves with, and what it means is that when the radiation goes to the molecules start to move a bit more. They become excited, we say, and then they only absorb certain wavelengths which are in the infrared, and then they also emit these same wavelengths in the infrared. This infrared radiation is radiated in all directions, up, back into space, and downwards. So basically some of this is radiated back to Earth, and therefore the Earth will heat up. What are the main sources of these greenhouse gases? Methane, water, carbon dioxide, and N2O. Each of them has a natural source, which is, for example, H2O is produced by the evaporation, and so on. Carbon dioxide is produced by forest fires, volcanoes, and so on, but also we produce some. Methane is produced by oceans, wetlands, lakes and rivers, but also some of our activity provides an extra amount. N2O is provided by forests, oceans, soil and grasslands, but also we produce them by burning fossil fuel. Now this is an interesting graph. We have to see that this is the downcoming radiation from the sun. This is the black body radiation emitted by the Earth. However, if you notice that water vapor here absorbs a great deal of the infrared radiation, but not much of the light, the visible radiation and the UV. So water is transparent to UV and visible, but it's fairly opaque to some parts of the infrared, like this area and this area. And the same goes for carbon dioxide. There's a particular peak in the infrared part of the spectrum where carbon dioxide is opaque to infrared radiation, but is transparent to other parts. And this is the problem. There is incoming radiation which is able to travel through the atmosphere in this area here, but then when this energy is re-radiated, it's absorbed by the atmosphere because it's re-radiated at a longer wavelength. So this is the absorption taking place, and these are the parts of the emission of the spectrum there. Now here is a kind of question which was asked in the past, and we'll look at this. we have the incoming intensity, which is I, 100%. 0.25 is reflected from the atmosphere, 0.15 is reflected from the planet's surface. Now, first question, what percentage is reflected by the planet? Well, it's 0.25 plus 0.15, which is 0.4, 40%. So what is the albedo of the planet? Well, since it reflects 40%, the albedo is 0.4. What percentage is absorbed? Well, if it reflects 0.4, it must absorb 0.6. So 60% is absorbed. How does the total intensity entering the planet compare with the total leaving? Now, if we know that the Earth absorbs 60%, it also emits 60%. Everything is fine. The Earth is in balance with the flow of energy. The energy that's absorbed is the energy that's emitted. So we have a stable situation here with the level of gases and so on that we have in the atmosphere. So what will happen to the temperature on the Earth if the I in is equal to the I out? Well, of course, if the intensities are the same, the temperature will stay the same. Now we're going to look at the consequences of different events. If we increase the number of greenhouse gases, what will happen? Which one of these factors would change? This would change from 0.6, let's say, to 0.55, and that is basically because not all of the energy is escaping. Only 0.6 was escaping for, now it's 0.55. Now we have the situation where the energy in is greater than the energy out. So what's going to happen in this case is that the Earth will very slightly start to heat up. But this will be short-lived. It will heat up until the Earth becomes warmer, and then it will radiate more energy, and that will be matched again, 0.6 by 0.6. However, in the meantime, the Earth has got warmer. So if we have a warmer Earth, it reduces the polar caps. So it means less snow, ice on the surface of the Earth. What effect will that have? Now, the amount reflected by the planet's surface will go from 0.15, let's say, to 0.10, 10%, because there's less snow. Which means that the amount coming in and being absorbed will be 0.65, not 0.60%. So here again we have another situation where the energy absorbed is going to be greater than the energy emitted. So what will happen is that the Earth will heat up, and this will carry on in a vicious loop unless it's controlled.